This is section 4.1 and we're going to look at graphing exponential functions. So we're going to start by looking at two functions. F of x equals x squared and g of x equals 2 to the x. Okay, so the first equation is a quadratic equation. The second equation is an exponential equation, and we want to see what these look like. All right, so we're going to start by just making a quick t-chart. So let's graph f of x first. So when x is 0, f of x is 0. Okay, when f of x is 1, x squared is 1. When x is 2, f of x is 4. When x is negative 1, f of x is going to be positive 1. And when x is negative 2, f of x is going to be positive 4. So these are the basic 5 points that we use to sketch a parabola. Okay, and then we can see the basic shape is a parabola. Okay, now let's look at g of x. So g of x equals x, 2 to the x power. All right, so let's start by looking at when x is 0. So when x is 0, I have 2 to the 0 power, which is 1. Okay, so I'm going to start by plotting that point. Okay, when x is 1, I have 2 to the 1, which is 2. So let's plot that point next. When x is 2, then I have 2 squared, which is 4. So 2, 4 is here. Okay, and then I'm going to look at some negative values. So let's look at g of negative 1. So g of negative 1 means 2 to the negative 1, which is 1/2. So negative 1 is going to give us 1/2. So negative 1/1/2. And then g of negative 2 is 2 to the negative 2, which is 1 over 2 squared, which is 1/4. So negative 2 is 1/4. Okay, and this is the basic shape of an exponential function. So what happens is as x gets larger in the positive direction, these values move to infinity very quickly. And as x gets small, as x gets more and more negative, this is going to get closer and closer to 0, but never quite reaching it. Okay, so this curve is the basic shape of an exponential function. Okay, so let's look at some more exponential functions. So in general, you only need a few points to graph these once you know what the basic shape looks like. So let's look at f of x equals 3 to the x power. Okay, so I start by thinking about my y-intercept. Okay, so when x is 0, 3 to the 0 power is 1. So when a is 1, these graphs go through 0, 1. Okay, then I usually think about when x is 1, f of x is going to be 3, so 1, 3. And then I think about negative 1. 3 to the negative 1 power is 1/3. So that's about here. So you can see the basic graph looks a lot like the graph we just drew. Oops, let me try that again. Okay, it just gets steeper faster. There's a vertical stretch here. and 2 to the x. Okay, 5 to the x is going to look pretty much the same, just a little steeper. So again, I just think about my y-intercept. My y-intercept is going to be 1. And then when x is 1, y is 5. And when x is -1, y is 1/5. So looks similar, just steeper. So when b is greater than 1, this is going to be the basic shape of the graph. So when b is greater than 1, your graph is going to be close to 0 in the negative direction. It's going to generally cross through 0, 1 if a is 1, and then it grows quickly in the positive direction. So this is the basic shape when b, your base, is bigger than 1. Now let's look at what happens when b is smaller than 1. So for these two graphs, and we know b has to be positive, so really we're thinking about when b is between 0 and 1. Okay, so let's see what happens. Okay, so I'm going to do the same kind of thing. I always start with my intercept, so when x is 0, 1/2 to the 0 power is 1, so I go through the same point here. When x is 1, 1/2 to the 1 power is 1/2. I'm just going to get a few more points on this one. So when x is 2, 1/2 to the 2nd power is 1/4. So I can see as x gets larger, the function gets smaller. Okay, and then when I move to the negative side of the graph, okay, 1/2 to the -1 power is 2. 1/2 to the -2 power is 4. So you can see that it's like a reflection. Where does a reflection across the y-axis? Okay, so that's 1/2 to the x power. 1/3 of the x power to the x power is going to behave similarly. So again, I look at my y-intercept, which is 0. So 1/3 to the 0 power is 1. Okay, 1/3 to the 1 power is 1/3. And 1/3 to the -1 power is 3. So we can see the same shape, just growing a little faster. So when b is between 0 and 1, you know that your basic shape is going to be like this. Oops, shouldn't have gone below there. Try again. That's wobbly. Okay, so the top, b is greater than 1. This is called exponential growth. And on the bottom, this is called exponential decay. Okay, so we can use these basic ideas to write equations for functions that are given. Okay, so we're given the graph, okay, of a function. We want to write the equation for it. So we can see that it goes through 0, 1. If it goes through 0, 1, that means it's of this form, right? We know that a is 1. Okay, and then when x is 2, the function is 25. So 25 equals b squared. So we know that b has to be 5. Okay, so this is the equation for this function. Okay, now here we see that we have an exponential decay. It goes through 0, 1. So we know we have this basic function. We know that b is going to be a fraction. Okay, we know that when x is equal to 3, the function is equal to 1/8. Okay, so if we take the cube root of each side, we find out that b is 1/2. So y equals 1/2 to the x power is the equation for this graph. Okay, and then we can use transformations to graph as well. Okay, so if we just remember our basic transformations, we can use the basic graph, f of x equals 2 to the x, to sketch each of these graphs. Okay, so we're going to start by remembering what this basic graph looks like. So this basic graph goes through 0, 1. It goes through 1, 2. And it goes through -1, 1/2. Okay, so here is our graph for f of x equals 2 to the x. Okay, so we're going to use that to graph each of these. Okay, so in A, 1 plus 2 to the x, that is a vertical shift. Okay, so for A, we're going to keep all the points the same. We're just going to shift everything up by 1. Okay, so instead of 0, 1, we're going to go through 0, 2. Instead of 1, 2, we're going to go through 1, 3. And instead of -1, 1/2, it's going to go through -1, 1.5. And instead of a horizontal asymptote on the axis, you can imagine a horizontal asymptote at 1. Okay, so when you draw this graph, it's going to approach the line y equals 1. Okay, now if we look at b, h of x, okay, the negative sign is going to take our original graph and reflect over the x-axis. Okay, so instead of the point 0, 1, we're going to have the point 0, -1. Okay, instead of the point 1, 2, we're going to have the point 1, -2. And instead of the point -1, 1/2, it'll be -1, -1/2. So it's going to look similarly, just reflected over the x-axis. Okay, and then for part C, when x is changed, we know that that's a horizontal shift. So this is going to shift the graph right 1 unit. Okay, so same as the original graph, everything just gets shifted right by 1. So instead of 0, 1, we're going to be at 1, 1. Instead of 1, 2, we'll be at 2, 2. And instead of -1, 1/2, we'll be at 0, 1/2. So there is the graph shifted right 1.